ERStudio Data Architect 20.2 now includes support for Databricks. As a summary of the new features for Databricks, we've provided core platform support, which means that you can reverse engineer directly the database and will connect to the Unity data catalog and perform that operation. We can generate Databricks DDL code from a model or also import it and create a new model. And a really important feature of ERStudio is through the compare merge tool. We can compare two physical models or a physical model and a live database and then generate an alter script to propagate those changes to the database. In terms of the features of Databricks that we support, so through the Unity data catalog we support the newer features around primary and foreign keys and check constraints. We also support materialized views, clustering and partitioning, Bloom filter indexes, function and mask functions in tables, views, and we've got some really neat features around how we handle denormalization, which I'll show you in a moment. So before we go to Data Architect, let's look in our Databricks Unity data catalog and have a look at the data set we're going to reverse engineer. So I've got a catalog called main, I've got a schema called trng_db, which has got some tables within it. So we hop across to Data Architect. I can select my ODB drivers. I've got a predefined Simba driver set up for my Databricks catalog. Our database list will show us the catalogs, and we're looking for our main catalog. We can then select the schema trng_db, and we can choose which object types we want to be able to reverse engineer. Again, we support views, functions, materialized views. There's the tables that we were just looking at. I've got options in Data Architect as standard to infer foreign key relationships. I can also choose a naming standards template to help me understand those physical names that we can see in Databricks. Okay, so looking at our physical model here, these are all the tables that we saw within our Unity data catalog with their physical names. If we go to our logical model, then the naming standards template system has given us some nicer logical names there. Going back to our physical model, we open up one of these tables. We can see the information that we brought in. So for each column we've brought in the data type and the length, nullability constraints, and the owner of the table. We can also see comments included in the database. We've reversed engineered those as well. Here we can see that the primary key constraints have been understood. If there's any things like identity columns, we'd bring all that in. If there was a mask function attached to a column, we'd bring that in as well. Looking at the table, we've also got information like clustering that we brought in directly from the database. We'll also collect information like the partition keys and various other properties of the table. We've also included some nice features in our design process for handling nested objects within Databricks. So like we did for our other platforms that support hierarchical systems like JSON, MongoDB, Google BigQuery, Databricks also got a similar sort of features. So here in this logical model, we can see that we've got an address object, which is related to our employee. Now to improve performance, rather than creating addresses as a separate table and then being able to read addresses for employees through a join, we're going to nest address inside employee to improve that performance. In our logical model, we can include a containment flag against the relationship and the direction of the containment. In this case, our employee contains our address. Now if I generate any system in Data Architect that supports nesting or hierarchical structures, it will automatically nest address inside employee. So if we generate a physical model for this right now, we select the Databricks platform, we choose naming standards template because we want to eliminate all the spaces and create nicely compacted names. You can see in our physical model that we've generated here, our address object is now nested inside our employee table. The naming standards template has created all those nice physical names for us. It's also created a view object based on the objects set in the logical. Once we've created our physical model, then we've got all those Databricks specific properties that we can set. So we can set partitions for our tables, we can set clustering values. We can also add Bloom filter indexes. And from here, as usual, we can generate our DDL code for Databricks. We can see our code, and there's our nested structure we were looking at in our employee table. So that's our support for Databricks Unity Data Catalog in ERStudio Data Architect 20.2. For more information, come and see us at ERStudio.com.